Check it out now, y'all.
nanoHUB-U, online instruction.
We're back to discuss the first homework problem in week 2 of the course. And this problem is just a very simple question to make you think a little bit about the tip-substrate interactions that we've discussed. So let's pretend we have a substrate. Let's pretend the substrate has 2 regions. One region is made up of gold. The other region is made up of copper. Somehow we've made the substrate so that it's a planar substrate that's perfectly joined in the middle between the copper and the gold. We then take a tip. Radius of the tip is 5 nanometers, and we somehow position that tip 1 nanometer above the copper, and then we move it over and position it one nanometer, we position it 1 nanometer above the gold, and then we move it over and position it 1 nanometer above the copper. And the question is simply, will the tip feel the same force due to van der Waals interaction when the tip is over the gold and when the tip is over the copper? So the way this problem has to be thought of is you first need the interaction potential energy between the tip of radius r and the substrate when the tip and the substrate are separated by a distance d. This equation was derived in the lecture notes. The proportionality constant is h, the Hamacher constant. In order to get the interaction potential energy due to the van der Waals interaction, to get the force from this u, we have to take the negative derivative of u with respect to the separation distance d, and we end up with an expression which is 1 over d squared times the radius of the tip times the Hamacher constant h. The Hamacher constant h can be approximated is the quantity pi squared times the number density of atoms in the tip times the number density of atoms in the metal times this fundamental constant c that describes the interaction potential energy between an atom in the tip and an atom in the substrate. So in this problem, we're going to assume that the constant c for the tip interacting with the gold and the tip interacting with the copper, we're going to assume that constant c is the same for both cases. It just makes the problem a little bit easier to solve. So if we want to calculate the ratio of the tip, the force when the tip is over the gold to the force when the tip is over the copper, it basically comes down to the ratio of the Hamacher constants in the 2 situations, because the separation distance d is the same. It's 1 nanometer in both cases. The radius of the tip r is the same in both cases. It's 5 nanometers, and we're assuming this constant c is the same. So a lot of these terms just cancel out when you take the ratio to calculate the ratio of the forces. And you're just basically left with the number density of atoms in gold compared to the number density of atoms in copper. So you can look up these number densities for the elements. I provided a chart in lecture 1 of week 2. And what I find that the number density for gold atoms is about 5.9 times 10 to the 28th per cubic meter. And if you compare that to copper, copper is about 8.45 times 10 to the 28th per cubic meter. So those are the ratios of the number densities for atoms of gold and atoms in copper. And that ratio works out to be about 0.07, right? So what this tells you is, that the force that the tip would feel above the gold substrate is going to be about 70% of the force that the tip feels when it's above the copper substrate. And that 70% difference is just due to the fact that there are more copper atoms per cubic meter than there are gold atoms per cubic meter. So I think the correct answer in the homework set is C, and I think that's how you solve the first homework problem.